Hello again. So, another brief non-calculus video. I'm going to look very briefly at the logistic functions here. Just because in previous videos we've looked at these graphs and we've never given equations for them. And now that we have the exponential function, we can give the equation. And the graphs I'm talking about are S-shaped graphs. I've talked about the spread of disease, for example, and I've said that a realistic graph might look something like this. Slow initial spread, followed by rapid growth, followed by slow growth as the disease comes under control. This is the example I gave when I first talked about concavity. So, what's the equation of a graph that looks like this? Well, notice that if I crossed out the part where the graph got under control, as it were, where the disease got under control, this would look a lot like an exponential function. And the equation for a graph like this has exponential functions in it. It is f of x equals a constant m divided by 1 plus a constant a times e to the negative kx. So, not the prettiest equation. Here's the graph of 1 on Desmos, obviously much prettier than my scrawled, hand-drawn things. So it's S-shaped. You see, I was going to cover the screen up with my hand. Probably not very helpful. But you see, this does initially look like an exponential function. If I move this so we can only see the negative numbers, this looks exponential, but then it levels out. And specifically, it levels out at 7. So the number in the numerator is a horizontal asymptote. What the other numbers do is maybe less immediately clear, but like if I increase the number in front of the E, we get a picture that's closer to the one I drew. Where now, just looking at the positive region, again, say this represents the outbreak of a disease, only positive time values make sense. The disease grows slowly initially, then it picks up speed and grows exponentially, then it flips concavity and starts to grow slowly. And that I said the word, it's occurring to me that I didn't actually write it down. But this is the form of the logistic function.